And so now let's look at the enum types. Okay. Yeah. So what is an enum? See, it falls in the category of the categorization is like whether it's a interface type or a class type. Okay. So enum is a class type. Okay. So what is an enum? Fine. An enum is just like a class. Okay. But it's a class where the objects are pre-created. Okay. And your objects are already created for you. Okay. Okay. And so enum is nothing but a class where we have fixed objects. You can't, so it's like in the class definition itself, the objects have also been declared, that these are the objects we'll be having, and whatever is declared in that enum, whatever objects have been declared, you cannot have anything, no new objects can be created. So it's a object class with fixed number of objects. Okay. So anytime, yes, we feel, okay, here is a thing where we have fixed number of objects. If we have such a class, yes, we can go for the enum types. Okay. Let's look at the syntax for defining an enum. Some of the things will be quite similar to a class. So it's almost just like a class. A few additional things. Fine. So let's see. So if we have to define a enum, okay. Okay. I'll also take an example here. Fine. As an example for a enum type, let's consider month. Okay. Month as a type which has got fixed number of objects. Fine. There are 12 objects for the month. Okay. So yeah. So we'll consider month as our month enum. Okay. Fine. The enum for the month type. How do we define this? Okay. To define a enum, we use the keyword. So you will have modifiers which are available. For example, yes, we'll say it is a public. Okay. The keyword enum is necessary. Fine. Followed by the enum which you are defining, the type which we are defining here. So it's saying, okay, month. Okay. Fine. I think what I can do here is just before this, I'll also post. It's like this. The syntax is modifiers. Okay. So fine. Any number of modifiers may be there. Then the keyword is enum. Then okay, enum name. Okay. Fine. We cannot have extends the way we have in a class definition. Okay. There's no extends clause here. Okay. But we can have implements. So there is an optional part which says, okay, we may optionally say it is implements and list of interfaces. Fine. And within this, in this syntax here, first part, there are two parts to it. First is a list of objects. Okay. Fine. To end the list of objects, we use a semicolon. Conventionally, we put it in a separate line. Okay. Okay. Even actually, the list of objects are separated by comma, and the convention again here is to put each object in a separate line. Okay. Then we'll see that. We'll follow that convention in the enum for the month. Okay. Fine. And after this, yes, what is it? Oh, this is just like any other class definition. So here, what goes in a class definition, right? So we know the members of a class. Okay, all those members which we have seen in the class definition, yes, they can go here. So it's after the semicolon, okay? After the list of objects and a semicolon that we have things which are just like a class definition. So a class definition is here, but before the class definition, we have said, oh, these are my objects. Okay, fine. So, okay, let's use this syntax. And so we have modifier. Here we have only one modifier, let's say public. Okay, a few modifiers like final or enum. We don't use the final or abstract. Yeah, we don't use such modifiers here for the enum. Okay, abstract is not available for the enum type. Okay, fine. And okay, fine. In our case here, we don't need any implementation. Fine, we don't have some interface to be implemented, so it's fine. Okay. And yes, then what are the objects we have? 12 objects. Okay. Let me use okay. Okay, the convention about these objects is again to follow capital letters. And they are more like constants for us. Okay. Okay. See, someone could just define, someone could just define an enum just like this, or that also is an enum. Okay, we can add more things. Okay, so if you want to add any of the members of a class definition, yes, we'll need a semicolon to be mentioned. Okay, and then start with the class definition. So yes, this is also a valid enum, the way we have put it currently. Okay, you might notice there is a comma at the end of the last element also, right? This is fine, it is acceptable. This is actually okay, fine. You don't put a comma, but even if you put comma for the last one, it has been allowed. Okay, the idea being that yes, you might change the order here. You might be changing the order of the objects here, so it doesn't matter. Like if you put a comma at the last one, even if you shift it somewhere upwards or downwards, yes, you don't have to worry about it. So that's the reason why we put convention is to put every element in a separate line. So yeah, if you are interested in changing the order for some reason, okay, the last comma for the last element. No, comma is not optional. Last comma, yes, last comma. Yeah, any list normally would be like this, right? Last additional comma has been allowed, you can say. Okay, fine. So if this is the way a enum like month has been defined, that means I have a type called month which has got 12 objects. Right? How do I access those objects? Anywhere else? Oh, this type has been defined. There is a type called month and it has got 12 objects. How do I access those 12 objects? So you'll just say month dot something like this. So this is an object of type month. You can say month m equals, and oh, this is a valid assignment. All of these, right, they are objects. So you can see these are nothing but static members of the type month. Okay, fine. Month is just like a class. Okay, fine. The enum is just it's as good as a class, right? So this is the class and it has a so whatever we have declared here, okay, that is used for creating an object. Okay, see, one thing we also noted was that yes, when we define the enum, we do not mention extents, right? We cannot mention extents. The reason is it's always fixed. If it's an enum which is being defined, okay, then we'll say, okay, all enums extend from a class called enum. So there is a class called enum in the java.lang package. Okay, fine. Okay, and therefore, yes, this is what we have, right? So the super type or super class, if you consider enum as a class, the super class for all enums is the class called enum. Okay. Fine. Another thing here, to have a subclass of this class enum, you can't, so this is one thing. Fine, we cannot create a subclass of enum, okay, other than by defining enum type. Okay, it's only the enum type which will become the subclass of enum. Right? And for example, okay, if someone says, okay, let me have a class called my enum extends from enum, okay, then that's an error. Fine. Okay. You can't have a subclass of the enum class. It's a compilation error. Okay, fine. So a few things about the enum then. Right? Let's have a look at some of the things related to enum now. Okay. So as far as the enum is concerned, the class enum is concerned, okay, it's anyway a generic class. Enum is a generic class. It says E, the type parameter is E. It's a bounded type parameter, which says E extends enum of E. The type parameter basically happens to be the same as the enum type which you are defining. Okay, fine. So within this, there is a type parameter E. E is nothing but your enum type. When it says extends enum, oh, only the enum types are subtypes of the class enum. Okay. Fine. So this is one thing. The enum class implements. Okay. So this is enum is a class. Okay. So this is how it is, like public class enum. It implements a few interfaces. It implements an interface called comparable of E. And why it needs a type parameter? Because yes, it wants to implement comparable of E. Okay, fine. There are a few methods and interface. Fine, comparable. A few other things which we haven't yet seen. It is implementing clonable. No, it's not implementing. Uh, Even if it implements clonable, one thing here, clone method throws clone not supported exception. Okay. So I'll show you exactly what they have done in this code for the enum class. Okay. One is it's comparable, it is serializable. Okay. Okay. Okay, let's see this. Okay. So within this, yes, whatever they have, right? Let's look at the methods, some of the methods which are available here. Okay. So any enum, if you are defining, it has a list of objects, right? You have put them as a list of objects. Now these objects have an attribute. Okay, there are a couple of attributes available for all objects. So it's like, oh, it has a private variable of type string. That's a name. Every object here has a name. Every object here has a ordinal value. Okay, there are public methods like this. There is a public method which says, okay, so public method returns string, method is name, and this method is final. Okay, it's simple. It has to return a name of the object. Okay, important thing, it is a final method, cannot be overridden. Okay, I'm just showing you some code from the class called enum. A method to return int, name of the method is ordinal, and returns the ordinal value. What are these two things? Okay, fine. So to understand them, yes, we understand we have given a list of objects. For any enum, we give a list of objects. So if we have the object called, fine, consider this object month dot jan. That's an object. Fine. It's under the enum class. Okay. Now month dot jan dot ordinal is going to be 0. Ordinal is 0. Month dot fab dot ordinal is going to be, what will it be? 1. Fine. It's giving you the index position. Fine. It's giving us the kind of index position, right? Okay. So ordinal is 1, and what will be, now this should be easy, month dot jan dot name. What will this give us? As a string. Okay, it's a string jan. Clear? One is a type month, so month dot jan is of type month, fine. Whereas month dot jan dot name is of type string. Okay, string type and month type. Okay, so they are separate things, right? On an object, yes, you can go for. So every object, whatever you are having, right? When you are giving the list, you are putting its what is derived by, because this class is getting created by compiling, right? You compile an enum, yes, and ultimately it's going to be a class. Okay, so what are the things it is doing? It is putting all those lists as public static final variables. Okay, fine. So it's like the month class having a public static final, type is month, name of the variable is capital Jan. Okay, and equal to, and it has created an object of the type month. Okay, with 2 parameters. One parameter says, okay, the ordinal value is 0, and other says the name is Jan. So from your list, two important things: the order in which you have listed those objects, that matters to us, and what are the spellings you have used for those names. Okay. Okay, so fine. So those two things. So enum has these things, right? Plus enum also says, oh, it implements comparable, right? What is the comparable? What is the comparison? Which is greater? Which is less? Int compare to, and the type is e. Yeah. Okay. Yeah. How do I write this? Return sorry return this dot ordinal minus e dot ordinal. So what is this? It automatically is the comparable. Oh, another important thing I'm forgetting here is this is final. See, methods being final means you are not allowed to change the. You are not allowed to override them. So for an enum, the comparison, it is having a, we say it has a natural order. The way you have listed the objects, that becomes the natural order for any enum. Fine. You cannot be overriding. Yeah, it's because when you're writing a enum type, it's a class, right? After semicolon, you can always be overriding the methods which are not final. Of course, there is another method which is not final. Let me also give you an example of a method in the enum class which is not final. Public string to string. This is not a final method, but yes, it's returning name. Name is final. You can't override and say, oh, I'll start giving a different name for this object. Name, ordinal, they are final. Compare to is final. What it has also done is it has said, okay, I'll also give you another public and final method. Returns object. Name of the method is, okay, it is an overriding method since it's overriding. Okay, the method returns object. Name of the method is clone. And what it has done here, it says, okay, if you call clone, I'll always throw a clone not supported exception. Okay, some messages there. Fine. So we have some message which is becoming part of the clone not supported exception. So enums cannot have a clone method working on them. They made it final so that no subclass can ever think about saying, okay, I implement clonable, let me override the clone method. No, clone, why it is not supported? Why clone should not be allowed? Idea is we have only so many objects. We cannot have new objects being created. Clone is always a copy, another copy of the object, right? No, it increases the objects of this type. No, for an enum type, objects are fixed. Your list is the list of objects. And so the definition defines what object will be there. Fine. So some important methods which we have here, okay, which you are inheriting. So you have these methods, right? Ordinal, name, comparison logic is always there, and that is fixed. You will not. So those methods you cannot override. But yes, of course, toString you found by default it just returns a name, but you're free to override in your enum definition. Okay.
Sir, can line 1914 return a negative number?
Return?
One negative number.
Yes, it returns negative if ordinal of E is, right? See, this is supposed to return less than 0, greater than 0, or equal to 0. If both are same, equal to 0. If it comes earlier, fine. If the current object is coming before the given object, it has to be less, less than 0, right? So comparable, right? It's nothing but the comparable logic. Okay, how to interpret this? Okay, fine. Over and above this, there are a few other static methods as well. I'll just put one of them if you want. Yeah, but okay, we'll see another thing about the static methods in the enum which we define. What are the static methods available to us? So we have another public and static method. So this is a static method where we have a type parameter E extends enum of E. Okay, fine. Return type is E. Okay. Name of the method is value of. And as a parameter, there are two parameters to be given. Okay. The order of parameters I don't recollect, but yes, one of them will be the class object. Okay. Fine. The class object for an enum type. To be more specific, question mark extends. Okay. So this is the class object. And the second parameter is a string for the name. It might be the first is name and then is the class object. Right? The order I'm not sure of. But the important thing to know here is that it says what this is doing for us is you give me a enum type. Okay, give me an enum type and give me the name of the enum object. I'll give you the enum object. So give a string. Okay, so something like someone saying enum dot, okay, month m is equal to enum dot value of, and I'll say month dot class. So that gives me the class object for the month type. And second parameter is I'm saying, okay, I want to give you the name, so give me the month object for this. See, here I have said string, right, as a hard-coded value. It's something which you might have taken from the user. And it's an input from the user, right? Okay, so a string and a class object. Fine. The order of these two parameters will have to be checked, but yes, given these two, right? And now, okay, so this is about the enum class. The class enum, what you get. Okay, clone never possible. Okay, now coming to some of the rules about the enum. There's one important thing related to the, I'll have to go back into this. Now, when I'm saying members of a class, okay, in this constructor, yeah, are always private. Constructors for enum types are always private. If you don't declare them private, it will be considered to be private. Okay, so default constructor for enum type is private. If you try to declare it as protected or public, that's a compilation error. You explicitly mention private or you don't mention private, it is considered as private. Fine. So trying to have a constructor, public constructor in an enum type, it's an error. Or a protected constructor in enum type, that's an error. Okay, fine. The reason is simple. No one should be allowed to create an object. Right? The reason is this is the list, no one else can create an object. So it is private. Okay. Okay. So fine. So now let's go and expand on the enum class, on the enum called month. Let's check something more in this now. Okay, I'll pick this up. Okay. Now, yeah, we would like to add something more in this class definition. Okay. I'll put a semicolon and then start again. So this is the, yeah. Now, can we have constructors? Yes. Right? But they would be private. Okay. Can I have variables, instance variables? Yes. So let's add first the instance variable, right? And then we use a constructor to initialize the instance variables, right? So let's add a instance variable. It's a private instance variable. Type is int, fine, and maximum number of days in that month, right? And you want to keep some default value of 31, maybe. When by default it is 31. Okay. Or you don't want to, you may not have initialized, fine. It's either way, fine. Okay. Let's now go for the, if this is there, yes, we would add a method called get max days, okay, to return the value, but we would also like to have a initialization. So have a private constructor, even if I don't use the keyword private, okay. The constructor, this is constructor, no return type mentioned, okay. And then it takes a parameter, right? The maximum number of days it has, yeah. And we can say this dot max days is equal to, that's a constructor. Oh, now if it is a constructor, when is the constructor going to be called? Oh, it's the list where we mention the objects, right? So when you mention the objects here, according to the constructor, you must specify a parameter. Okay, you must specify the, so just following this, yes, I'll say, oh, this is 31 and maximum days here is 29, max days here is 31 and so on. But I can always be overloading the constructor here. Okay, and I can also provide a no argument constructor. Okay, it's not doing anything. In that case, the default 31 which I mentioned here, that should be valid, right? And therefore I would be allowed to, for Jan I don't put anything, for March I don't put anything. Where it is different than 31, yes, I'll put them. Yeah, yeah. So just like a class, have a variable, right? You want to have static variables, yes, you can have static variables. Anything which goes in a class definition goes here. You want to have a static method, it's available, right? You can have anything. Yeah, you want to write a static block, yes, you can do that. You want to put an initializer block, you can do that. Okay, fine. So we have constructors, and of course let's also add a public method which returns int get max days. Okay, and it will say return this dot max days. And methods, public methods can be there. Okay, fine. Then, oh, you might add another attribute. Okay, I have just given one attribute. Use to make it better, yes, we can even have a string. Okay, full name. Yeah, no default value, but let's take it as a parameter, right? I think we can keep it as a first parameter, string. Okay, and okay, and this dot full name is equal to n, and okay, keep it as a parameter here also, string n, and yeah, here I might actually be better off using this n comma 31. Yeah, and even if I don't initialize here, that's fine. Okay, so the constructor, now there are two constructors. It requires a string at least for giving us a full name. So now you can go and update this. Okay, so everyone has to have a construct invocation of the constructor. This is, so when you are listing, actually you are invoking the constructor. You don't have to say new here. Right? Okay, so we can always be In the list, yes. So this is the list. When you are writing, you're actually putting the invocation to a constructor. And if you have a no argument constructor available, yes, you will not even mention the brackets. Okay. When clear, so constructors are available, and that's the only place where we use it. Okay. And now you might like to even override the toString method. Oh, let's even override the toString method. So what's the toString method now? Public string toString. And what toString should do? Return this dot full name. Okay. Fine, clear how a enum is just like a class. Fine, class with a list of objects. Okay. Fine. Want to try this? Let's just quickly try this out, and then we'll look at another case also. And there's still something more remaining about the enum type. Yeah. But clear, any questions you have now? Okay. What I'll do is let's put this as a enum in our folder. Okay. In our src folder. Yeah. We can keep it as part of a package. So let me put a separate file here. Okay. Let's create a package. We'll have our own package. Let's call it util package. Okay. Fine. Okay. So this will have to save as month.java. When clear how this month has been defined. See, for any enum, when you are defining, if you want, you can keep implements here. But if you are saying implements, chances are you will have to override those abstract methods from that enum. Fine. Okay. Okay, so let's change this. Let's save this. Or, okay, I'll change the toString method slightly more. Okay, it just says full name. Okay, plus. Okay, or rather than this, let's say month colon plus this plus, and we would like to also indicate what are the number of days it has. Okay, colon plus. Okay, so normally you'll say this dot max days, or instead of this, let me. Okay, toString is just returning month, and then it says whatever the name of the month. Okay, has so many days. Okay, so let's save this as month.java under the util folder. Okay, and this will be called as, so this will be month.java. Okay, so we've saved it as month.java, and let's now compile and check. Fine, compile and then we'll test the code. Yeah. Okay, so Java C minus D backslash bin. It is util backslash month.java. Okay, yeah, this has compiled. Okay, fine. Let's use JShell to test it out, right? Let's try it out. Okay, we'll have to write a main method somewhere, right? So one option is, yes, enum also can have a public static void main. So you could have done it in a main method in this, but let me just do a JShell minus class path. Backslash bin. Okay. Okay. Let's have an import util.month. Okay, now we can use something like this. Month dot jan. Okay, let's see what is month dot jan. Yeah. So you can test a new one, right? It's just showing according to the toString method. Okay. Right. Then yeah, comparison. You want to see the comparison compared to? Okay. So month. Okay. Another important one, right? Now you wanted to get the object by using the name. Okay. And so you have someone giving us, okay, string name equal to, and let's say it says name is, okay, okay, and so we have a string called name, which is the value for the October month. Okay, and now yes, you can ask for enum dot, what was it, value of, and what do we pass as parameter, month dot class comma name. Okay. Oh. And it is giving us that object. Okay, when you can change the name to, right? Okay, fine. So we can check on this, right? Anytime. So one way of getting an object given a name is this. Okay, now another important thing which is related to the enum, let's see this. Okay, let me put it here. Okay, not in this place, sorry, it's here. Yeah, all enum types, okay, get a couple of static methods. One, okay, so one method for getting all the objects of the enum type. Okay, you can get all the objects of the enum type in an array. Okay, and second, okay, and this okay, fine, for the enum month. Okay, So if the enum is month, then how it is, what is the method signature? So if the enum is month, then the month enum. So any enum it may be, right? So accordingly you'll have to change. Okay. So because the enum is month, we have a public static method in the enum called month. Okay. And this method should return us a month array. Name of the method is values. Another static method which returns a month. Okay, name of the method is value of. It takes a string name as a parameter. Okay, so example will be, we can say month dot month array all months is equal to month dot values. Okay, that's one example. Another example could be month m is equal to month dot value of, and you could be passing a string here, some string here. Okay, yeah, yeah, these are just the examples, right, of using them. Okay, so instead of month, any enum whatever you have, yeah, that's what you'll replace here, right? So in the enum called, maybe you have some other enum, whatever enum you have, so for that, yes, you'll have the method returning the array of that type only. Okay, so we have fixed number of, let's say we have another class called operators. Yeah, so we have operator, we have fixed number of operators, and we can say, okay, all the arithmetic operators, let's say we want to have a enum for all the arithmetic operators, right? Okay, fine, we'll try that also next, right? So this is but this is clear with the two static methods available for any enum type. Whenever you define an enum, you'll have these two methods available for your enum type in the enum itself, in the type itself, right? So month dot values give us all the objects of the month type. So this you will get in the same order as the order in which you have mentioned in the list. And this is by value. Okay. Now the convention is we always follow the, what is the convention? All capitals for the names. Okay. All capitals for the names. Okay. Fine. So now let's just try out, and we'll have one, let's try in the month class, in the, sorry, the enum called month. Let's put a main method here. Fine, and we'll try to run this. Okay, so we can have a main method. So at the end, let me put the public static void main. Okay, so we are taking some command line arguments here. So what we'll do is we'll take command line argument as name of the month. Okay, fine. So we'll say string month name is equal to args of 0. So the first command line argument is the name of the month. Now he may not have given it in capital letters. We'll need to convert it into capitals. Okay, fine. So we can use the two uppercase, right? So now I can get the month object is equal to month dot value of, and or okay, I'll keep it as month name here, but yeah, one of the two places we'll have to do this. Okay, so what I've done is, yes, whatever that command line argument he has passed, and we'll convert to uppercase and keep it as a month. So fine. So normally, yes, that's what should be done. So when you say value of, you are using all capitals, and we are following a convention where we'll always use all capitals. Okay, fine. So now the one who is using this, he has the freedom of, okay. So system dot out dot println. Yeah, Okay, let me just print month itself. I think the toString method takes care of giving the message properly, right? Okay, so yeah, 3-line code for the main method, fine. And let's run this now. Okay, we'll need to compile. Okay, fine, and then we can run the code. Util dot month, we'll have to pass some parameter. Okay, but we can use lowercase there, right? But okay, okay, fine, fine, clear on this? Okay, fine. Enum just like a class. Okay, a few more things now. Okay, let's go for another enum. Okay, let us go for another enum. Enum for the arithmetic operators. Okay. We have the public enum called arithmetic operator. Okay, which are the arithmetic operators? Add. Okay. Okay. Now we'll keep right at the beginning. Let's decide that we will have some parameters to this. One parameter will be what is the symbol used. What's the symbol? And this is plus. Any other thing which you would like to do? No. Okay. Fine. So this is saying plus, comma, subtract is minus. Okay. Yeah, we are going to have constructor and a variable, in a private variable for this, right? The symbol which is used. Multiply. Okay. Divide. Modulus. Okay, fine. So these are the arithmetic operators, and yeah, so we have the private variable of type string symbol. Okay, fine. We have our private constructor for arithmetic operator. It takes a string as a parameter, which is used as a symbol here. Okay, and we'll provide a public method to return a string. Okay, get symbol. We'll have this dot symbol is equal to, yeah, sorry, return this dot symbol. Okay, and let's also override the public string. Okay, I think it's better to return the symbol. Okay, now for any arithmetic operator, we must have a method called compute. Right? So we want to have a method called compute. Okay, let me put it before any other thing. Yeah, I would like to have a method called public method returns double. Name of the method is compute. Parameter is a double A and a double B. Okay, how do I write the implementation of this? If the object happens to be add, then it has to return a plus b. If the object happens to be subtract, it has to return a minus b, right? See, it all depends on the object. It's different for each object. The method is compute, but the implementation of the method is different for each object. Okay, fine. So what we can do is we can say, fine, this, since it is different for each object, let me declare it as abstract here. I declare it as abstract here and go to each object and put my definition for this method. See, when we write in enum, look at the syntax now. Okay, a new syntax is coming now. Okay, what we have done, our enum has an abstract method now. It says, I can't write the implementation of this, which works across all the arithmetic operators. It's different for each object, right? And then I go to each object and say, okay, here I would like to specify the implementation of the compute method. Open braces, put a block. So the syntax of an object in the object list is name, okay, in parentheses calling the constructor, followed by this is, see, all this is optional, right? Okay, so now you can say, okay, let me now override the method. Okay, public double compute double a comma double b, fine, and then return a plus b. Each one of them is giving his own definition. Okay. Okay. Now, one thing I'll do here is I haven't. Okay, let's. So this is how it can be done. The idea is this. Is this clear now? What we have done? Our enum contains an abstract method. Not a problem. You can have an abstract method in your enum, but in such a case, for each object, you must specify the implementation. So here, object wise, you are overriding the method. The object in object list has a name, okay, calling the constructor, so parameters, and then you can have open a definition where you are overriding the abstract method. It's not only abstract method you override. It's not only that the abstract method is being overridden. Okay, I'll show you something which we can do even with the month on these lines. Okay, you don't have any abstract method in the month enum, right? Okay, but let me override the toString method for the object February. Yeah. So I can put here also. See? Fine, has so many days, right? Oh, yeah, I think I have added days after that, right? So I'll have to override. I won't be able to use super.toString. Okay. Okay. This has okay. Fine. So we can have it like this. So for a specific object, we are overriding the method. Okay. Fine. We have checked with the month class definition already. We have tried it. I'll go back to the. I've not saved this, right? Okay. Let me go back and show you something here. Okay. What do we have? Oh, there's month dot class. Okay. We have got month dot class. Next, let me save this. Okay. Fine. Let me compile this. There's some problem. This dot full name. Okay, where have we done this change? Okay. Yeah. We have the method get full name, right? Okay. I think what's the method name then? We didn't provide a method for getting the full name. Okay. Oh, let's add the method then. Public string get full name. This dot full name. Okay, now let's compile. Oh, it has compiled. Okay. Now I want you to look at this directory. How many class files? Right? For month, right? The enum month which we have written has got two class definitions. Which are those two class definitions? One is the definition for the month. What's the other definition then? What's the other definition? This here, right? From here to here is a definition. This is definition of a class. In a class definition, you override a method, right? Okay. So this is nothing but it's a class which is a subclass of your month. That's why you are overriding the method of the month here. Further overriding the method of the month. Okay, so when we use this kind of a syntax, right, we are actually creating one more class definition. This is actually a definition of a class. So this object, the feb object, is of a class which overrides a method of the month in this manner. Okay, so at object level, I can specify overriding of method. Each object, when it is created, can say, no, I am not of the same type, I am a subtype of this. Because I do it differently here. I am overriding some method. I want to override a method. Okay, fine, clear? Okay, I'll show you something more on these lines. Okay, let's look at another example here. For this, I'll go to JShell. Okay, let's go to JShell. And we'll use JShell with class path. Okay, fine. Let's import bank.star. Okay, fine. And I should now be able to use account. Account is abstract. Call the constructor. Okay. See? Immediately following a constructor, while creating an object, immediately following the constructor, I can override a method. I can give my definition and override some method over there. Okay, so for example, yes, how do we want to override a method? Any of the methods? You want to override which method? For account class, maybe you want to override the, okay, let me do it this way. Public string. Okay, let's override toString, right? Or any other method. Want to override the deposit method to do something different? Okay, so public void deposit takes long amount as a parameter, has a throws for yeah, I don't want to put the throws here. Okay, fine. See, an overriding method cannot have additional throws, right? But it may remove the throws. I'm not going to check also whether it's negative or not. Okay, not checking if it's negative. Right? And let's say what I do is this dot balance plus equal to, okay, and then amount into 0.90. So 10% is to be deducted more. I'm not depositing the full amount. Okay, but this I'll have, since I'm putting 0.90, I'll have to cast it as a long. Right? Or saying I can also do it like this. I can even say super dot deposit. Okay, fine, do it like this, but then I'll need the throws because I'm calling deposit here. It will require a throws. Okay. Fine, so this is what I have created, right? That's of type becoming of type double. We'll have to do a casting. Okay, cast into long. Lossy conversion. Okay. Deposit cannot override deposit. Bank return bank. It's not compatible with the bank. Acha, okay, let's just check. Oh, super dot deposit. Return type is void, right? Or have we returned something? Okay. I should just then say, I think what we did was we said we'll return the account object itself, right? Maybe this is what we might have done. Yeah, that was the case. Okay, so now there is a deposit method here, which is different from the account class deposit. See, this is, I can show you why we had to do this change. Return type was account. The reason, this is how it is in the super class. In that account class, this is how it has been defined. It is saying public account. Okay, let's show this. Okay, I'll show the code. And return type was not void, but return type was kept as account, so that we can do chaining. Yeah, here account class. Look at the deposit method which we have. Yeah, deposit return account. Return type is account here. Okay. Okay, so here I have created an object. Now let's check. So it shows there's a balance of 1 lakh. Okay, AC dot deposit. How much? Deposit 1 lakh more. Let's check. It's 190. For this object, yes, that's how it is working. So you have changed the definition. You have given one more class definition. While creating an object, anywhere, while creating an object, you call the constructor, and immediately following the constructor, you can put your definition. This object behaves differently from the class. Okay, I want to do something different here. Okay, so I have a new definition for this object alone. It's only for that object. It's not for all the objects of that class. Getting the syntax, while creating any object, fine, we can do this. What's the name of that class? Oh, we have given a class definition. What's the name we have given? Oh, we don't give a name here. We have not given a class name to a class definition. So this type of class, it's a class definition again. We call it as anonymous classes. And these type of classes are known as anonymous classes. And we have seen the need in the arithmetic operator for anonymous classes. Okay. Fine. So whenever there is any class definition exists, then the compiler is supposed to create a class file for it when it is compiling. And that's why we get a class file. And how is the class name going to be decided? The name of the file. It says fine, the class is month, I have month.class. But there is something inside the month. Okay, so $1, the first class definition is $1. Okay, arithmetic operator. So what do you think arithmetic operator will give me now? We haven't put it yet, right? We have to put the, fine. We want to put the definition for the arithmetic operator now. Is this fine? Any questions? Yeah, about the anonymous now, anonymous class. Anywhere you are creating an object, right? Immediately following the object, open braces and put your definition for that object. Specifically for this object, that's how I want to do it. You may override a method here. Clear? The syntax is new, call the constructor, put braces and put your definition for that object. This is supposed to be extending from whatever new you have mentioned. You're saying, oh, it's a new object of account. Okay, fine. Then it's overriding it's a subclass of the account. It's a subtype of that. It's not only class that we do it in, fine, we do it in an enum also. And we could be doing it for an interface also. Okay, we could be doing it for a interface. I'll show you for an interface, but first I think what we can do here is, let's pick up this definition of the arithmetic operator and let's try it and let's see when we compile what happens, and then we'll also try it with the okay, so here let me pick this code. Okay, so that's a code for the enum called arithmetic operator, and now let's have a definition for that enum in a separate file. Okay, again this also will keep it in the package called util. Okay, enum called arithmetic operator. Yeah. Okay, so let's save this. Okay, we can compile this. Okay, it compiles. And let's look at that directory now. For each of those 5 operators, we have created a separate class definition. There is arithmetic operator, right, which is the enum type and subtypes, where we are overriding for each object. So every object has its own class definition now. But they are all subtype of the arithmetic operator. Right? So anonymous, their class file names will be like this, right? Wherever in whatever class definition you have used it, okay, within that, right? So that name $1, $2, like this, okay, and then the class name. The first occurrence of a definition is $1. Second occurrence of a class definition, anonymous class definition, is going to be $2. Okay. Here, so every class definition which you are having has a class file. Okay, and yeah, with J shell Oh, we wanted to also see about a interface, right? Using an interface. Okay. Okay. Let me put a main method in that arithmetic operator now. Okay. Let's put one main method. So this is the arithmetic operator where we are saying, okay, let's have a public static. Okay. So what do we do? Take some inputs from the user, and for example, user will say, he'll mention the operator which he wants to use, and he mentions two values. So three command line arguments. And what we do is we carry out the arithmetic for it. Okay, call the compute method. Okay, so first we have a string operator name is equal to args of 0 dot to uppercase. Okay, fine. Second one we can keep as double a is equal to double dot parse double args of 1. Okay, so second command line argument used as a value for a. Okay, string to be converted into double type, right? So we use the parse method here. Okay, double b is equal to double dot parse double args of 2. Okay, and then let's print. Or okay, before going for a print, what we have to do is we have to say arithmetic is equal to value of, right, and we'll say upper name, and getting the operator object, and then let's give an output system.out.println. Okay, and what do we do? A, right, plus space, okay, plus operator, okay, plus space plus b plus equal to plus, yeah. Now we would like to apply that operator compute method. Yeah, and we are picking up, fine. When there are three command line arguments. First one is used for getting the name of the operator which you want to use. Second and third are the values to be passed to the compute method. Fine. So from that first one, we picked up the operator, right? And then we are saying, okay, a plus, and whatever is the name of the operator. Fine. This toString method is giving us the symbol, right? We have overridden toString to return the symbol, right? Okay, and then the second, then equal to n. Okay, what is the result of calling compute on that operator? See, look at the entire code. There's no condition check anywhere. There's no if statement. You don't have to check, oh, if the operator is this, then it should be add, right? Each object has its own way of doing his own computation, right? So there's no if involved in this entire thing. No condition checking. Okay, and let's run this code. Okay. And oh, you want to do what? Subtraction, multiplication, and add what? Let's say add and okay. And you could change and run it again. Yeah. Let's change those things as 7.7 and 2.5. And instead of subtract, let's take the modulus. Anyway, double type, yeah, they are not precise. You get such things. And instead of modulus, you want to do a division. Okay. Fine, clear? See, we have two things we have done actually today. One is we have learned about the enum type, and second is about the anonymous classes. Achha, I wanted to show you the syntax for using interface with anonymous, right? I'll just quickly do it on J shell. Okay, I should have done, sorry. I'll do it with the class path. Okay. And what we do here is we'll say, okay, we should have an account array first, yeah. Okay, I think I'll be better off doing it in the main method of the test account. There we have the array and we are doing the sort. A lambda would be a much better choice than going for an anonymous class, but that's how it was being done earlier. Before lambdas, how the things were done, how the sort method was written. Let me show you that also, fine. So, okay, let's go to the test account. Okay, so in the test account, yeah, we are doing this sorting, right? So we have the name comparator created like this. Okay. Okay, let me add a few more lines, but look at the syntax which I'm using here now. And then it override public int compare. And comparator has a method called compare. And that's what I want to override. Okay. Public int compare parameter. It's a comparator for account, right? The arrays of account, and therefore I'll pass and return that one is for this. I think, yeah, brackets match. Okay. And so this is my test account class. Okay. It has used an anonymous class. See, anywhere I want to pass a comparator object here. Okay, new comparator and pass this. I have created a comparator. Okay, so it's nothing but a class which implements a comparator interface. Create object of a class which implements a comparator. Let's compile. Oh, sorry. Then we have the test, right? Backslash test account.java. Okay. Yeah, at the rate override. Does not override compare to objects. Yeah, okay. I think I need to mention here. Okay. It's a comparator of account. Okay. And just so when we say new comparator, also mention the type parameter, comparator for the account. Now, yeah, okay. The thing to look out, first thing, this is anyway going to work, but directory dot backslash bin backslash test. Test, yeah, you can see test account and test account $1 dot class, the anonymous class. Okay, yeah, and if we run the code, that's going to run. Okay, the last one is after the okay, we just copied pasted it, so it's the same thing, but it's going to be the same because this was ignore case we have done, but we have written the code separately. Okay, and this is just to show the syntax for writing an anonymous class. Anywhere you have an object, yes, you want to create an object, anytime you can create an object and give its separate definition, and you can override some methods of that class or interface, whatever it may be. Right? Only thing here is you don't get multiple inheritance. Right? You can't be saying, oh, I want to create an object of some class which extends here and implements this interface also. It's only one super type. New super type name. Use its constructor. Okay. Fine. So any questions? Yeah. Any questions on the enum and also the anonymous class? Okay, fine. The next thing is going to be on nested types. Fine. Fine. So any questions? Yeah. Fine. Clear about the enum? Fine. It's a list of objects and a class definition. Okay. Fixed number of objects. Each object you can have constructor. Fine. If you have constructor, yes, call the constructor. Fine. You can use anonymous class syntax there also. Okay. Fine. So we continue tomorrow then. Yeah. Okay. Have a nice day, everyone.